Dear students, very good morning. Today we are going to see one important problem in Cauchys type of differential equation. So the problem is here. The question is solve x square d square y by dx square plus 4x dy by dx plus 2y equal to e power x. So this is the problem. So for this we are going to write the solution now. As I have mentioned already, the given problem is of Cauchy type. Okay, so in between the problem I shall tell you what to do when a given problem is of Cauchy type. Okay, so solution, first write a given equation x square d square y by dx square plus 4x into dy by dx plus 2y equal to e power x. The operator form for this is x square d square plus 4xd plus 2 into y equal to e power x. Okay, so now you can say the given problem is of Cauchy type. The given problem is of Cauchy type or Cauchy Euler type. This equation is called Cauchy Euler equation. Okay, Cauchy Euler type. So substitute x equal to e power z, z equal to log x, then x d equal to d dash, x square d square equal to x square d square equal to d dash into d dash minus 1. Okay, so these are the substitutions that you are going to use. So take this as equation 1. When you substitute these things in equation 1, the equation 1 will become see x square d square is replaced by d dash into d dash minus 1. So you are getting d dash into d dash minus 1 plus xd is replaced by d dash. So plus 4d dash plus 2 into y equal to e power x. So e power x means what is that? X equal to e power z. So you will have e power z. So here comes the toughness. Okay, so because here you are having e power z, right? So here comes the toughness. This toughness is making this problem as very important. Okay, so now we are going to simplify this problem. So d dash square minus d dash plus 4d dash plus 2 into y equal to e power z. This implies d dash square plus 3d dash plus 2 into y equal to e power z. Okay, now for this equation you can write the auxiliary equation. How will you write auxiliary equation? In order to write auxiliary equation, you have to replace d dash by m. So this implies m square plus 3m plus 2 equal to 0, and this implies m plus 1 into m plus 2 equal to 0, because the product should be 2 and the sum should be 3. The two numbers satisfy the condition is 1 and 2. So 1 plus 2 equal to 3, 1 into 2 equal to 2. So the factors are m plus 1 into m plus 2. Now you are having m1 equal to minus 1 and m2 equal to minus 2. The roots are real and distinct. Real and unequal, real and different, real and different, distinct, unequal, anything you can use. Okay, so now when the roots are real and distinct means the complementary function is given by a e power m1z. m1 means what? Minus 1 into z, plus b e power minus 2 into z. Okay, so here you have to note one thing. Okay, here you have to note one thing, that is here d dash is denoting d by dz, whereas the given problem d is denoting d by dx. Okay, so everything is, when it is d dash y means it is dy by dx, when it is dy means it is dy by dx. Okay, you have to keep in mind that. Now the complementary function is given by a e power z whole power minus 1 plus b e power z whole power minus 2. Now what is e power z? You know what is e power z? X equal to e power z. Therefore a complementary function equal to a x inverse plus b x power minus 2. So till now there is no toughness. The toughness is the risk, everything will be in finding the PA. So what is your given question? 1. Now to find PA equal to 1 divided by d dash square. Okay, that is we can split that. Okay, d dash square plus 3d dash plus 2 into y equal to e power z. So this is your initial step of writing PA. So in this, how I am going to proceed is I am going to factorize the denominator, so that I will get 1 divided by d dash plus 1 into d dash plus 2 into e power z. Now I am going to use the method of partial fraction. Okay, during your school days you have learned it by method of partial fraction. I can write this term 1 divided by d dash plus 1 into d dash plus 2 equal to a divided by d dash plus 1 plus b divided by d dash plus 2. Okay, now we can take the LCM, so that a into d dash plus 1 plus a into d dash plus 2 plus b into d dash plus 1 equal to 1. So you are having a d dash plus 2a plus b d dash plus b equal to 1. So here I am going to equating the coefficient of d dash. So what is the coefficient of d dash? On left hand side, a plus b. Okay, you don't have the d dash term in the right hand side, so I can write it as 1 plus 0 d dash. So now tell the coefficient of d dash on right hand side is 0. So a plus b equal to 0. This implies a equal to minus b. This implies a equal to minus b. Now I am going to equate the constant terms. Okay, equating the constants. The constant on the left hand side is 2a plus b. Okay, so 2a plus b equal to constant on right hand side is 1. Okay, so now 2a plus b equal to 1. You already know what is a equal to minus b. So this implies minus 2b plus b equal to 1. So minus b equal to 1. This implies b equal to minus 1. When b equal to minus 1, what will happen to a? A equal to minus b. This implies a equal to minus of minus 1, a equal to 1. Okay, a equal to 1, b equal to minus 1. Okay, so now you are having 1 divided by d dash plus 1 into d dash plus 2 equal to 1 divided by d dash plus 1. Okay, 1 divided by d dash plus 1 minus 1 divided by d dash plus 2, because b equal to minus 1. You can also verify whether it is right or wrong. Okay, how to verify? Just cross multiply these two things. D dash plus 2 minus d dash plus 1 equal to, see, d dash minus d dash becomes 0. 2 minus 1 equal to 1. So this is correct. 1 divided by d dash plus 1 minus 1 divided by d dash plus 2. So by partial fraction, we are finding the values of a and b. So this will become 1 divided by d dash plus 1 minus 1 divided by d dash plus 2 into e power z. Okay, now I am going to split this pi. 1 divided by d dash plus 1 into e power z minus 1 divided by d dash plus 2 into e power z. Okay, so now see, in the denominator I am having plus 1 and here I am having plus 2. I want to remove this so that I can solve the problem a little simple way. Okay, I can solve this problem in a little simple way, so that I am planning to add and subtract some term in order to eliminate this plus 1 and order to remove this plus 2. So now I am writing d dash plus 1 into e power z, e power minus z, e power z. Okay, minus 1 divided by d dash plus 2 into, I want to remove this 2, so e power 2z, e power minus 2z into e power z. Okay, have you understand my idea? So I can take this e power minus z outside. When I take this e power minus z to the leftmost end, what will happen? This d dash will become d dash minus 1. So that minus 1 and plus 1 will get cancelled. Remaining two terms are e power z and e power z. Okay. And the idea here is to take this e power minus 2z to the leftmost end, so that I will get here d dash minus 2, then plus 2 we will get cancelled, so 1 by d dash. Okay, so I am writing e power minus z 1 divided by e power minus z 1 divided by d dash minus 1 plus 1, okay, plus 1 into e power z z minus 1 divided by, here I am taking what I am taking here I am taking e power of minus 2z, so e power of minus 2z into 1 divided by d dash minus 2, then plus 2 into e power 2z e power z. Okay, now this will become e power minus z 1 by d dash of e power z e power z minus e power minus 2z into 1 by d dash of e power 2z into e power z. Okay, now e power minus z into what is 1 by d dash? That is 1 by d dash means integration with respect to z. So integration of e power z e power z dz minus e power minus 2z into 1 by d dash means integral e power 2z can be written as e power z into e power z, okay, into dz. E power 2z can be written as e power z into e power z. So now I want to look into something which is common. What is common? This e power z is there and you are having e power z here, and here also some e power z is there and you are having some e power z. Okay, I know that integration of e power t dt equal to the same e power t, or the differentiation of e power t, okay, differentiation of e power t is also same. I know these two things, so I want to utilize one of these two things. So let us see what I am going to use. Okay, so the first thing is I am going to take let e power z equal to t, then or we shall take like t equal to e power z. Okay, let us take t equal to e power z. That will be very convenient. Let t equal to e power z, then you will get dt equal to e power z dz, right? Okay, now I am going to substitute these two things in the integral. Okay, now e power minus z into integral, what is e power z? T into e power z is t. Okay, dz e power z dz means, sorry, just a minute, here let us make some changes. I shall write this e power z first, e power z into e power z dz, okay, minus e power minus 2z into integral. I am writing this e power z first, then e power z dz. Okay, so that now I will have e power minus z into This can be written as e power. What is e power z? E power z equal to t. E power z dz. E power z dz is dt. So e power t dt minus e power minus 2z into integral. This is e power t. E power z is t. E power z dz is dt. You understand what I am trying to tell? This e power z is becoming e power t. This e power z dz is becoming dt. Okay, this e power z is becoming e power t. This e power z is becoming t. This e power z dz is becoming dt. Okay. Now you can easily solve this. See what is happening. E power minus z integral e power t dt is here minus e power minus 2z into integral t e power t dt. Okay, so here it is normal integration. Here you have to apply the Bernoulli's formula. Okay, so now here, so I shall expand this. What is Bernoulli's formula? Bernoulli's formula is integral u dv equal to uv minus u dash v1 plus u double dash v2 minus etc. Okay, so integral t e power t dt means you have to find u equal to t and dv equal to e power t dt. As I have already mentioned, this term will not be changed. E power t is always e power t and differentiation integration. So u dash equal to 1 and v equal to e power t. U double dash equal to 0. V1 equal to again e power t. V2 is also again e power t. The formula is uv minus u dash v1 plus u double dash v2. Since it is becoming 0, all our terms will become 0 after u double dash. So t e power t dt equal to uv is t e power t minus u dash v1 is e power t plus u double dash v2 is 0 and all the terms will become 0. Okay, so I am going to substitute here. Here I know e power minus z. Integration of e power t is e power t minus e power minus 2z into integration of e power t dt is t e power t minus e power t. Okay, now I am going to replace all my substitutions. Okay, so this can be written as e power z whole power minus 1. This e power t is what? E power z, okay, minus e power minus 2z into what is t? You know, we have substituted just before t equal to e power z. So t equal to e power z into e power t equal to you know e power z. E power z minus e power t equal to e power z. Now it will become e power z. What is e power z? X equal to e power z. So x inverse e power z is e power x equal to e power z, right? So e power x minus e power 2z is nothing but I have to replace it here, but I have forgotten to replace that. Okay. Here you have to write e power z whole power minus 2. E power z minus e power z whole power minus 2. So this will be this See, this will be, what is e power z? That is x power minus 2 into e power z is x equal to e power z. So x into e power z means x e power x minus e power x. So this is equal to x inverse e power x minus, here it is x power 1, it is x power minus 2. So you will get x power minus 1, x inverse e power x minus into minus will become plus, x power minus 2 into e power x. Okay, so now these two terms will get cancelled. These two terms will get cancelled. You are getting x power, you are getting pi equal to, you are getting pi equal to x power minus 2 into e power x. So what is solution? Solution equal to CF, complementary function, plus particular integral pi. So CF is a x power minus 1 plus b x power minus 2. A x power minus 1 plus b x power minus 2. This is y of x is the solution. A x power minus 1 plus b x power minus 2 plus pi is x power minus 2 into e power x. Okay, so here you are having y of x equal to a x power minus 1 plus b x power minus 2 can be taken as common. So b plus e power x into x power minus 2. Okay, so this is the required solution. This is the required solution. So I hope you have understood the problem. So thank you for watching this problem. This problem is such an important problem. So please go through this. On the next video we shall see some other important problems on this topic. Okay, so thank you all for watching this video once again.